All right. My name is Matt McInerney. I'm the director of the Digital Scholarship Lab at Texas Tech University, and I'm also the former chair of the Texas Data Repository Steering Committee. I'm pleased to welcome you to the next session in our series of webinars on topics in research data management. First, let me orient you to the Adobe Connect platform. At the top left, you should see the attendees pod where the names of the webinar hosts, presenters, and participants are listed. In the middle left, you'll see the chat pod where you can type your questions, comments, and links for everyone to see. You can also directly message individuals here. At the bottom left, you should see the download pod where we've shared a PDF of today's presentation and TDL's most recent annual report. You are welcome to download these documents at any time during the presentation. I'll give you a brief introduction to the Texas Data Repository, or as we call it, the TDR. It's a multi-tenant Dataverse application launched by Texas Digital Libraries in late 2016. Dataverse is an open-source web application used to share, preserve, cite, explore, and analyze research data. There are 11 TDL member institutions who serve in the TDR steering committee, and they provide feedback and help make decisions on TDR services. The purpose of the steering committee is to provide strategic planning support and policy oversight to ensure the focus and direction of our programs and services. Texas Digital Library and the Texas Data Repository Steering Committee have presented this free webinar series since 2018, showcasing topics in research data management and hosted by experts in academic libraries throughout North America. You can follow the link on the slide to view previous webinars and slides. But before I hand things over to today's speaker, I want to remind everybody to please use the chat pod to ask your questions and leave comments. There will be time at the end for Q&A. Leah and I will be monitoring the chat for any questions during the presentation, and we'll call attention to them at the end. But now I'd like to introduce Hannah Hadley. She is the Data Curation Education Librarian at Pennsylvania State University and the project manager for the IMLS Data Curation Network. She, members of the Data Curation Network, and selected Data Curation Primer authors will be presenting Data Curation Primers, collaborative resources for data curators.
Thank you so much, Matt. And I want to thank Jessica Trologan, Alexandra Suarez, Leah DeForest, and Matt McInerney from TDL for having us here today. And I just want to give a little background for what I'm talking about today. So the Data Curation Network is a Sloan grant-funded shared curation project. We did a previous webinar with TDL. Lisa Johnson did that back in December of last year, and she explained a little bit about the network. What I'm talking about today is our subgroup on education. We are an IMLS grant-funded project that has created specialized data curation workshops, and a product of that is the Data Curation Primers. And we also do other workshops and instruction and other resources for education. And our IMLS grant number RE8518004018 has allowed us to have 3 free specialized data curation workshops. The first was co-located at the DLF Forum in October of 2018. The second was at Johns Hopkins University in April of 2019. And the third was at Washington University in November of 2019. And here's a glimpse of our workshops. These are 1.5 days in length. Workshops are interactive, collaborative, and heavily hands-on. In addition to lectures, we have group activities with sample data types, tool demonstrations, topic demonstrations, such as de-identification for sensitive or human subjects data. Workshops are also where primer creation usually begins. And primers are concise resources for the data curator. They're also collaborative. We will see examples in just a moment from the authors. But first, let me give you a little bit about the primers. Primer creation is approximately a 6-month process. Workshop attendees self-select into authoring primer groups on the second day of the workshop. DCN mentors are assigned to assist each group on their project. Each group will meet monthly to work on their draft. At 3 months, the drafts are peer-reviewed, Drafts are then revised and published around 6 months to a repository on GitHub. And we chose that because it's a collaborative platform. The resources are not meant to be static. They're expected to version over time with new and updated information, and that is something that the community can participate in. This next slide shows an example of a published primer. This is the confocal microscopy primer. And just to give you a little about the primers, each primer has an overview table, so you can quickly see if the resource is right for you. There's also components in it, such as the key questions for the curator or clarifications that you might ask the researcher for. There also might be discussion of metadata standards or tools. Other helpful information may also be included, such as surveys or interviews that are conducted by the authoring groups. And this slide shows you the primer topics that have been explored for each of the 3 workshops. And you might notice that the 3rd workshop on the bottom, they're still in the process of creation. The 2 on the top are published currently. And we also have primers that are being created within the DCN, and we're also beta testing some authoring groups that are independent of the workshops. And now I'm very pleased to introduce the authors from some of our primer groups. And the first author that we have from the Microsoft Access Data Curation Primer is Fernando Rios. He's a research data management specialist at the University of Arizona.
Thank you, Hannah. I worked with Dave Fearon on this primer for data curation for Microsoft Access. And yes, I can advance the slide. Okay. So just a brief overview of what MS Access databases are and what they're for. MS Access is a widely used relational database system in everything from business for orders and inventory. In the sciences, we have use cases such as using Access to collect raw data, field samples, and so forth. In the social sciences, we might have cases where people use Access or other relational databases to collect survey data or collect data from specific field sites or artifact metadata. One use case that I've seen a lot is also people using it just to manage their lab. So keeping track of lab supplies, tracking experiments, and so forth. The main curation issues that I see with Access are, well, number one, it's Microsoft. It's a proprietary system. It's not really documented, so it's really difficult to for it to interoperate natively with other things. Related to that, it's an opaque file format with a lot of different versions and different formats. And there's really no quick way to distinguish between them. So two files with the same, two MS Access files with the same extension might have differing formats in the background. And really what I see is the biggest curation challenge is that there's a huge variation in how people use Access, and huge variation in not only the complexity of databases, but also people's proficiency in using relational databases. So oftentimes best practices aren't really followed, which makes things a little harder. So the key challenges, the first one is this format issue. So Access comes in, you might see different formats, different file extensions. One is the MDB file extension, and the other one is the ACCDB. The vintage of MDB is the older format. That was the default up to Office 2003. Newer versions of Office created in this ACCDB format. However, even with those MDB and ACCDB differences, there's still differences within each of those formats, which means that not every, say, MDB file can be opened in every version of Office, for instance. The Library of Congress actually has a really good page on the technical details of the differences between these formats. So I won't repeat all the information that they have, but we have a link to that resource in the actual primer itself. The key challenges, another key challenge is that there's kind of a lack of preservation standards for databases. There are a couple, but they're not in widespread use, and more importantly, for Access, they don't capture the special features that Access has, and the biggest reason why people use them. And those are things like creating forms or graphical interfaces, or creating scripts or reports. From the fairness point of view, most databases are really they're far away from being curation ready, meaning that they're usually kind of impossible to understand unless you have the person who created it, sitting beside you explaining what to do. And they're not always self-contained, which could be a problem for preservation. Some key considerations that I'd just like to highlight are when it comes to curation, looking at what the complexity of the database is could inform how you approach curating it. So if you have a simple database that just consists of maybe a few tables, it doesn't have any forms or fancy queries or macros, you could kind of really curate it like you would a spreadsheet. But others that are more complicated are obviously going to need more work. But it kind of as a base level, something we proposed in the primer was, to keep the original files, but also, if possible, export some of these to a flat CSV file. And critically, what you want to capture is the relationships, right? Because this is a relational database system, so that's really the key point why somebody would use this. So we really want to capture those relationships. And Access is nice because it has a nice tool called the relationships diagram and a database documenter that generates some of this for you. Now, obviously, for more complex databases, you might need help from the creator to kind of explain what the relationships mean and how the data is actually supposed to be used. A couple issues that I think we should take a look at kind of as a next step would be to hopefully work with people that do database curation and in the community to establish what a minimum level of curation would be versus like an in-depth level of curation. And this gets back to that thing I mentioned earlier, where there's really a huge range of use cases and proficiency levels when people use databases. Next is exploring how third-party tools might enable curation activities. And this is to address the fact that, Access is proprietary. So how can we more easily and consistently open these files and maybe extract some data from them in an automated way? And then finally, how can we take work from the academic literature around database curation and migration to enhance the primer itself? And in that sense, I'd like to point to the work of Andrea Tomar on database migrations. And if you download the PDF of the presentation, you can actually click the link and it'll take you to a paper. But that's all I have, I think, for this. So I'll pass it on to the next speaker. Thank you.
Thank you so much, Fernando. And our next speaker is going to be from the SPSS Data Curation Primer. Jeanine Finn is the Data Science and Digital Scholarship Coordinator at Claremont Colleges.
Hi, good afternoon. Thank you. We worked with the SPSS software package, which is a statistical and software package used primarily in the social sciences. Oh, there, I can't advance it, yay. It is primarily used in social sciences fields like psychology, education, often for early career researchers. These are folks who are often taking their first quantitative analysis class or are fairly new to some of the data analysis that they're doing. And they're often introduced to the software in the graduate programs. The thing to sort of keep in mind, as Fernando mentioned with the Access database issues, that this is a proprietary software. It is not open source. It's not cheap. But it has been in use for quite a while for some of these fields in the social sciences. So I think it's currently on maybe version 25 or 26. And if you've taken a quantitative analysis class in social sciences in the past 20 or 30 years, you've probably worked with SPSS. Oh, and I did want to mention my collaborators. I worked with Shahir Kahir, Cy Deng, Joshua Dahl, and our mentor, Sophia Lafferty, has. And part of the work that each of us did in putting together this primer was to speak to some of the researchers about what they found troublesome in sharing data with SPSS, how they used it in their work, what was important to them. We looked at the file types from SPSS. The SAV is sort of the standard file type. A POR is a portable file type that is a fairly new introduction in SPSS. SPS is a text file output. Most folks working with SPSS will sort of know these extensions and know where they normally do their daily work and sort of put their daily output. SPSS, the way it is structured, it has some built-in metadata as opposed to external readmes. Most of what you need to keep in mind during a curation process is make sure that you understand how your researcher or your team of researchers has been using it. It's possible to just get into SPSS and do a terrible job naming your variables, not explain things, not document properly. You don't want to get handed a proprietary data format that doesn't have all these things sort of built into it. And again, the question, as with a lot of other formats, the preservation actions, you want to sort of consider whether or not you want to export to plain ASCII text or not. The recommendations from some of the bigger repository services, including ICSPR, LOC, and some of the Dataverse sites. The good thing about SPSS is that it's been around so long, people have worked with it. They've tried to open up data from 20 years ago, which is not something you can say with a lot of these formats. And the recommendations generally seem to kind of say do both. Save your file type, your proprietary file type, because it has so much embedded into it and some of it is somewhat opaque. So save that proprietary format as well as save a plain text file with the data, the variable names, and create a text file to sort of give instructions as to how it opens up. And ICPSR has done really a very good job of sort of explaining this to their researcher community, and we look to them for a lot of guidance on how to sort of create sustainable preservation models for this. It's good to keep in mind SPSS versioning if you're working with several researchers, maybe collaborating. SPSS is not great at backwards compatibility, so you do want to keep in mind what they're using and how they're sharing it among their collaborators. Future thoughts, one thing all of us, Shahira, Sai, Joshua, and Sophia, sort of all encountered in our research communities at our different institutions was that SPSS is sort of increasingly seen as a transitional format. You are able to export it to a variety of formats within SPSS, and open source data analysis and visualization options do have packages to open up some of the content of SPSS files. We talked to several people who are really doing most of their statistical work in R and RStudio, and there is a package that I think is just called SPSS to R that can pull data out. So sort of keeping in mind how the use is emerging on your campus and how people are sort of moving more into open source solutions if they can, if they stay in their field. So that's one thing to consider with your curation questions. And also keep in mind, like I mentioned, ICPSR, Library of Congress, Dataverse, SPSS has such a history that those social science repositories and how they're actually putting into practice some of these materials and their decades, literally, of experience are very important. So we're going to sort of revisit that as we keep looking at the primer. That is all. So I think I can turn it over to the next presenter. Thank you.
Thanks so much, Shanine. And our next presenter is from the PDF Data Curation Primer group. This is Peace Awesome Williamson, who is the Director of Research Data Services at the University of Texas at Arlington.
Hi, everyone. I'm going to be talking about the PDF Data Curation Primer. I somehow lost the link. The title used to be a link, so I went ahead and placed it in the chat box. So you can click there to access the PDF primer in its current state. Can you hear me? I see somebody typing. But anyway, if you can't hear me, let me know in the chat.
Peace, you sound fine. You could be a tiny bit louder, but otherwise you sound great.
Okay, thank you so much. So yeah, you can access the PDF primer at that link. Also, this was not created in a vacuum, of course, as Hannah described. I worked with Nicole Contaxis, Margaret Lamb, and Adam Kreisberg, along with our mentor, Jake Carlson, on this. And we like to kind of start with some suggestions for feedback. So as you look through my slides, some of the things that we were having trouble coming up with, it is possible because PDF is such a widely used format, we were unable to really develop sections around unresolved issues and further questions. We've also added some elements PDF specific to the curated checklist. However, we're happy to hear feedback around that checklist and other ideas that people may have. So about the PDF, PDF is the preferred format. It's an open format, so ever since version 1.7, it's been published as an open format by the International Organization for Standardization, and that kind of breadcrumbs there are a link to the PDF format webpage on their website. It is the de facto standard for online published documents, so it's well used, well understood, and typically people know PDF and they're able to use it for various purposes across industries, disciplines, and types of research. It's preferred for documents because it preserves not just the content of the documents, but also the structure. So even fonts, styles, and other elements that are not present on that computer, the person who's viewing it, they're still it maintains that fidelity in that document. Also, since it's an open format, there are numerous software that can be used to create, read, edit, and convert PDF files, including, of course, Adobe Acrobat products, but there's also things like Nitro PDF Reader. There's a command line tool called PDFTK, and numerous others that we've listed within the primer. Now a little bit about its most common uses. So as you all probably know, PDFs are used for pretty much everything. Sorry about my slide is a little bit wonky there, but one use of it, we kind of broke it down into three. And the first one is data description. So the idea of code books, data dictionaries, README files, exported survey instruments, and so on is kind of what we're categorizing as data description. The second category of reporting methods and results are things like research protocols, figures, and the manuscript itself, with the last category being use of PDFs for data storage and sharing. So the data itself can often be shared as a PDF. Now, our recommendations are for broken down into these categories, and they go into obviously a lot more detail in the primer. But the idea of data description is to repeat information as often as necessary. So one thing to think about is the idea that there may be metadata in your data repository that you might want to repeat in the README file, so that when someone downloads that zip file with your data, they also download the information about that data along with it. So things like the creator's information, project information, description of the data files, abbreviations and measurements, variable names, data types, what's acceptable for that variable, and null values. So we want to make sure that the information is detailed enough and duplicated as it needs to be. We also recommend having it in an editable format as well, so having two versions, because oftentimes PDFs and other document files are easier to read than, say, a TXT file, like human readable, whereas other files are much more machine readable. So having both versions, where one is for someone to peruse and the other is for someone to actually take action on, can be very useful for reuse. For the second version, which is reporting method and results, we want to add things that will help inform the data use. So the idea of how will someone use this data later on when they don't have access to you to ask you questions. So adding in visualizations, even informed consent documents showing people's consent to having their data shared can help with reuse, or how that reuse is, what reuse is allowed. Also, write-ups about the methods that were taken can help in interpretation of the data. Lastly, as you can see, it's crossed out. Data storage and sharing is not recommended in a PDF format. Data are best shared in an actionable format, so we highly recommend that data are made available through reuse-ready sharing that's fit for the purpose, or also called source file sharing. However, a PDF of data summaries, once again, that human readable element with maybe means, distributions, a quick snapshot of the data can also be really helpful, along with the data in an actionable format. Lastly, I'll talk about some of our considerations for curation, which is a few of the elements that we added to that curated checklist. So being aware of the purpose of the file and what someone will do with it afterward. So going back to that idea of, is it useful in this format? Once again, probably useful if you're talking about someone perusing information about the data, but we want to make sure that there's machine readable data or other tools like the data dictionary that can be integrated into common tools that are used for that type of research. Other things to think about are converting into PDF A3, which allows for embedding files, and repairing PDFs if there are any issues. Once again, you can always visit our primer to see the full description, and we're happy to receive feedback. Thank you.
Thank you so much, Keith. Our next presenter is going to be from the GeoJSON Data Curation Primer. Raina Murray is a geospatial data curator and applications administrator at Johns Hopkins University.
Thanks, Hannah. Hi, everybody. I'm going to, in the chat, share our primer as well in case anyone wants to take a look at it while I talk. And before I get started, I just want to acknowledge my other teammates who worked on this primer with me, Rachel, Genevieve, Nadia, and Kashav, and then our DCM mentor, Mara. So GeoJSON. GeoJSON is a geospatial data interchange format for encoding vector geographical data structures. This includes things like points, lines, and polygon geometries, as well as their non-spatial attributes. And as the name implies, it's based on JavaScript object notation, and it continues, also known as JSON, and it continues JSON's lightweight, plain text, and machine-readable format, which makes it a really nice, versatile file type for web-based mapping platforms and applications. The GeoJSON file format, in particular, it takes several types of JSON objects to represent the structure and layout of geographic features, as well as their properties in their area. An important thing to know about GeoJSON is that it supports a single geographic coordinate reference system, which is WGS84, with in units of decimal degrees, usually up to about 7 decimal places of precision. And that image to the right is an example of a GeoJSON file, just trying to give you guys an example of with one that shows as many of the different GeoJSON types as possible. So that's a feature collection, which is made up of several features, such as a point, line, string, and polygon feature. There are 9 GeoJSON types. There's 7 case-sensitive geometry types, which are point, multi-point, line string, multi-line string, polygon, multi-polygon, and geometry collection, as well as then 2 other types, the feature and feature collection types. And one of the reasons why we looked at GeoJSON as a group is that there are several advantages to GeoJSON that make it a good option for encoding geographical data. Unlike some of the other presentations that were done, GeoJSON is an open file format. It's not proprietary. It's text-based, it's editable in a text editor. It uses common English words, which makes it very easy to read. And it utilizes a fairly simple data structure. And it's not only easy for humans to read, but it's also quite easy for machines to read. Also, for anyone who's worked with geospatial data, one of the not fun things that often happens is that you might be dealing with a lot of different files for one data set, whereas GeoJSON is a single file. And because of this, it makes it a fairly ideal format for consuming and producing some types of geospatial data. You often see it as a download options in geospatial data repositories or open data portals, or when using certain APIs. We do note a standard there on our slide. RFC 7946 is the official documentation for GeoJSON, and that's maintained by the Internet Engineering Task Force. The current documentation was put forward in 2016 and replaced the original documentation, which was released in 2008. And so it provides specifications for GeoJSON, including the syntax for GeoJSON objects. One thing I want to note is that curators may encounter the Esri-JSON file format, which looks very similar to GeoJSON. However, Esri-JSON is a proprietary Esri standard for encoding spatial data in JSON structured text. And one thing to be aware of is that if you are using geospatial desktop software like ArcGIS Pro, when you can transform a spatial data set from one vector file format to JSON, Esri-JSON is set as the default conversion type, not GeoJSON. So that's just something to keep in mind that when you receive GeoJSON file formats, it's sort of to check for that. And we have an explanation of how to identify Esri-JSON file types in our primer. Okay, next slide. So in terms of key curatorial considerations, these are some of the questions that we thought were most important to ask when looking at a GeoJSON file. Our coordinates listed in the following format: longitude, latitude, elevation. Can the file be opened and viewed? This is, I say there in a text editor, but I should also note that you want to make sure you can open it first in a text editor and then also in a geospatial desktop software package like QGIS or ArcGIS Pro or ArcMap. We also ask that you check to see if the file passes validation, and validating GeoJSON can be done can be conducted on some web-based validation services. One of the ones that we took a look at and recommend is GeoJSON lint. And linting is basically the process of running a program and that analyzes the code for potential syntax errors. And GeoJSON lint lets you just sort of copy and paste GeoJSON directly into the provided text box, and then you're able to quickly see whether or not the file will pass validation. With regards to a metadata file, you should check and see if there is a metadata file or a README file document, if it's complete. Is there metadata stored in the GeoJSON file? We provide, in our primer, we talk about how you can sort of check the metadata, check the GeoJSON file specifically to see if there's metadata stored in there. And then in terms of doing, we suggested that you convert the GeoJSON to shapefile file format and then save that along with the original GeoJSON file. And document the versions that you create in an accompanying file format. One of the reasons why we recommend the shapefile is that while GeoJSON is a relatively young file type and it's widely used and it's become one of the most common file formats for spatial vector data, especially for web-based projects, we did a survey and noticed that 100% of our respondents said that they regularly create or use shapefile data, while only 11% said that they reuse data in GeoJSON format. So shapefiles continue to kind of be a very common geospatial file type, even though it's proprietary. And given this, to sort of make sure that your data has, to ensure broad data access, we recommend converting GeoJSON files into other file formats, shapefile particular, but we also sort of suggested looking into geo packages as well. One last thing to note here is that there's currently no metadata standard for GeoJSON, and as there's no particular standard, we recommend that the curator select a metadata standard that best fits the repository's needs or policies, and we talk about these recommendations in our primer. I think I am running out of time, so I'm just going to sort of end by saying we definitely welcome a lot more feedback and ideas on our primer. Some of the future directions that we weren't, or the concepts that we weren't able to cover in our GeoJSON primer at the moment include incorporating TopoJSON, which would allow us to talk about raster data sets, and then also including more about investigating the geo package further and how that can be used in addition to GeoJSON file format for curation purposes. And with that, I will pass it on to the next speaker. Thank you.
Thanks, Brena. I'll introduce the next speaker, or the next speakers, I should say, from the GeoTIFF Data Curation Primer. Now, this is one from the third workshop that is in progress. We have with us John Watts, who is the Director of Research Data Management Services at Texas A&M University, and Courtney Kearney, who is a Scholarly Engagement Librarian in Physical Sciences and Data Management at Tulane University.
Thank you. This is John. Hi all. My colleague Courtney and I will share a little bit about our work with curating the GeoTIFF format. Courtney and I collaborated with Mara, Jessica, Tracy, and Nick, listed there on the right. And a little bit about GeoTIFFs. GeoTIFFs are raster images that describe and store associated geographic information, including geographic coordinate systems and projections. As part of our work, we surveyed researchers who use this format and found that these are a preferred format for sharing geospatial analysis across platforms. So they are meta tag or GeoKey embedded, allowing the geospatial analysis to be stored in the TIFF. These are files that work across different platforms, both proprietary like ArcGIS platforms, as well as open programs such as QGIS. They are popular with researchers due to their portability, flexibility, and the unique capabilities to encapsulate varied geospatial analytics. Our next slide talks a little bit about some of our key curatorial questions that we devised based on what we found from our survey and other information. I think GeoTIFFs can be a little tricky to curate due to the complexity of embedded data. They require contextual metadata and documentation to promote reuse. And we developed the following questions. This is a pretty truncated list, so the primer hopefully will break some of these down. But the first is, what are the parameters? What were the measurements or the purpose of this file? For example, is it a time series analysis of satellite images to perform land cover classification and land use? And if so, then what is the temporal resolution? What are the time units that are embedded in the TIFF? When and how was this image acquired? Was it by satellite and sensors? And if so, what type of sensor and which satellite? What is the sort of chain of custody for the data embedded in the file? Also, what's the spatial resolution? So are there geographic coordinates present? And if so, look for the specific datum, the unit of projection, or the bounding box used in the file. Other questions are, does the data contain multiple layers or bands? And each band should include metadata describing the nature of that band and its composition. Also, are there missing values? And if so, they should be replaced by 0, which is expressed as a 9999 or no data value code, or for a string of codes, it's simply not applicable. So these are some of the questions and recommendations. Curators are also encouraged to keep other files associated with the GeoTIFF in a package, so in a zip file for curation. This is typically the data used in the analysis. This could be tabular data in a CSV, could be GeoJSON, as we just discussed, or shape files. The GIS software packages, such as QGIS, can extract data and metadata from a GeoTIFF image into these formats and then stored alongside the original GeoTIFF. So these are just a couple of considerations for the curator, and through the course of our primer development, we also identified some emerging practices for GeoTIFF creation and description that Courtney's going to share with you right now.
Thank you, John. So yeah, there are a couple kind of emerging practices, technologies sort of, that we as a group started to pick up on through our research about GeoTIFF. The first is GeoBlacklight. So GeoBlacklight is actually a kind of new schema developed by Stanford Libraries. It's user-friendly, it's discovery-focused, and it aims to improve interinstitutional sharing of files. So it allows users to add actually metadata to individual layers, which is a great feature for multi-band GeoTIFF. However, it may pose more like a larger workload on curators, so it's something to think about when working with GeoBlacklight. Another kind of emerging trend in GeoTIFFs is this idea of the cloud-optimized GeoTIFF, which is called a COG. So the main difference between a COG and a traditional GeoTIFF is strictly the order of the file components. So because of by shifting the order of these components, these files can be hosted on a file server where users can then request a specific portion of the file. By requesting a specific portion, it means the files downloaded are smaller and easier to process. It also reduces the data duplication, so a single file can live on one server and be accessed by multiple institutions, and improving kind of the streaming process and reducing download times. It should also be noted that GIS software is able to treat COGs just like a normal GeoTIFF, so they won't see them as any different than more traditional GeoTIFFs that we are more comfortable working with currently. And that's kind of all we have for GeoTIFFs. Thank you.
Thank you so much, John and Courtney. And our next group is from the Neuroimaging Data Curation Primer. This one is also from the third workshop and currently in progress. And we have as speaker Helen Mary Sheridan, who is the Data Services Librarian at University of Pittsburgh Health Sciences Library System.
Hi, thanks for having us. All right, so I have my long list of contributors here. And I want to thank them all for working so much on this because, let's just click this button. Yeah, so we did a topic-based primer on neuroimaging data, which, I work in a health sciences library, so a lot of my experience with neuroimaging data comes in the clinical and medical research realms, whereas the other folks in the group, some of them work primarily with, let's say, biologists who are scanning shark skeletons and looking at fish brains. And so we have a lot of different use cases here that informed the making of this primer. And we're seeking to address really the conceptual idea here of neuroimaging data and what do you do with it when it comes into your hands. So the first distinction that we're making here is the two primary file formats that are used across disciplines here in this domain. One of which is DICOM, that's the Digital Imaging and Communications in Medicine format, which is primarily used and developed by equipment manufacturers. So if you take a SAM and you put it in a CT scanner, that data is going to come off in DICOM format. DICOM is ubiquitous. It's non-proprietary. It was developed in part so that, if you have a clinical environment that's using scanning equipment from different manufacturers, they can, in fact, work together. And its real value is the depth of information that it provides with every single image a communication or scanning piece of equipment creates. So with DICOM, you typically have one two-dimensional image embedded with rich metadata that could involve things like patient name, time of scan, referring physician, et cetera, et cetera, et cetera. And if you imagine, this isn't a real number, but 30 scans, slices of a brain, well, you're going to have 30 two-dimensional images, all with that metadata embedded. The other format that comes up a lot in neuroimaging data is NIFTI. That's Neuroimaging Informatics Technology Initiative that was developed out of an older format called Analyze. And what that's really meant for is a streamlined file format developed for research analysis. So let's take the core information in DICOM, for example. So we want the actual image itself, and we want spatial information. How was this image taken? You know, what do the three-dimensional pixels called voxels, what do those correspond to? How was this original object oriented in space? And then that gets recorded in the NIfTY file format. They tend to be much smaller because they don't necessarily have nearly so much information. They tend to be less personally identifying when you're dealing with people, not fish, and they're really meant for research analysis. And then finally, the third concept that we treat in this primer is BID, so the brain imaging data structure, which is the most commonly recommended metadata standard for organizing neuroimaging data and metadata. Commonly recommended, I would not necessarily say universally used, but as a curator, you may be interested in conforming with that, and you may be working with people who did their best to comply with this. So comparing DICOM and NIfTY in a little bit more detail, what we discovered in interviews with two professionals, so one of whom is a biologist and primarily does, you know, non-medical scanning of fish, of sharks, etc., and the other who does primarily functional MRI of, you know, actual clinical patients' brains, is individual researchers will use both depending on their typical domain, like whether they are based in a clinical setting versus, you know, in the lab, and the degree of identifiable information that they either want or want to avoid. So typically, everything will come off the scanner, like I said, in DICOM file format, and you can keep it there if you find the high resolution or the exactitude of the metadata that is embedded in the DICOM file worth your while. So compared to NIfTY, DICOM files tend to be large. That's in part because you're taking so many slices very often when you're looking at someone's brain. And they're all images. They all have metadata embedded. Whereas NIfTY very often is smaller. I wouldn't necessarily say small, but in part based on how DICOM can represent images in a raster versus vector-based format, there tends to be more information encoded there. NIfTY tends to represent things more numerically. DICOM is produced in a clinical setting and often used in a clinical analysis setting, whereas NIfTY is for research applications. So if you are pulling EHR data and then looking at it, you know, with patient information, you're probably going to still want to reconcile that with DICOM information. NIfTY is not going to do you any good. And then hand in hand with that, and this is what I think the next group will address, is that DICOM brings with it a high risk of disclosing personal health information, whereas NIfTY, because it doesn't have so much embedded metadata, naturally has a lower risk of disclosing PHI. Now, if you are a curator and you are asked to convert them, you will want to make sure that personal health information, if it was present, is properly removed. That is not necessarily your responsibility, right? That should be something that the researcher did. But A, you want to check for it. B, there are many tools that can double check and do some removal anyway. And even with NIfTY, there is a risk of PHI, for example. The horrific term for removing facial features from an image is called defacing. So you may want to deface these images yourself so that they can't be recognized. And typically, that's a one-way conversion. So there are a lot of tools to convert DICOM to NIfTY, but you would rarely want to go the other way unless you need to re-upload it to a PACS, a clinical information exchange system. And so it's possible, but not as necessary. So this is a primer in progress, so we've submitted this for peer review, but we're still eager to hear from folks. If you have handled DICOM or NIfTY data and you have any questions or pain points that you need addressed. We're discussing several tools for identifying personal health information, neuroimaging data. but we are not comfortable making strong recommendations for particular methods and tools. So everyone in our group is very excited to look at the human subjects primer when that comes out. But does the community want specific recommendations? And then finally, we are interested in investigating more about BID metadata. How can that be mapped to other metadata standards? How genuinely useful do researchers find it? And how much can we be doing to support its greater implementation? And that's it for me. Thank you.
Thank you so much, Helen Marie. And our last speaker is from our internal group, internal to the DCN, the Human Subjects Curators Interest Group. Jen Dara, who is a senior research data management consultant for Duke University. She is also a DCN curator, a workshops instructor, and a data curation primer mentor.
Thanks, Hannah. Hopefully everyone can hear me okay. All right, so the impetus for this primer is basically due to the fact that all of us internal to the DCN, all of our repositories have to take data that has no identifiers in it. And we are all faced with sometimes getting data on human subjects, and there's a concern of, are we following everything we need to make sure that the data that we get can then be released into the wild through an open access repository? So human subjects data, as it says here, our scope is any research or information or physical samples taken from human beings that's either subject to IRB or other regulatory approval, used consent forms, or where the data presents ethical quandaries due to human subjects content. So this is considering data that has both direct and indirect identifiers. The fields that could use human subject data, as you can see, is a huge list. I mean, it's medicine, public health, neuroscience, biomedical engineering, psychology, sociology, demography, et cetera, et cetera, et cetera. So there's lots of different fields where human subjects data may be collected. So we tried, because this is kind of a humongous topic, to rein ourselves in a bit to kind of cover some key things as we would consider when we're curating the data. So, for example, is there an indication that the research was governed by a review board? That could be an IRB, that could be some sort of community board, it could be tribal, or is there other sort of regulatory protocol that could be associated with the data? Is there a copy of the consent form included with the data? We found that this is an extremely important thing to take a look at. Does the data contain any direct identifiers? Does the data contain any indirect or quasi-identifiers? And I'll get a little bit into that here shortly. Does the data contain any uncoded text responses? Or does the data contain links to other data sets that could lead to re-identification of research participants? So if anybody's ever followed Latanya Sweeney, that's a huge thing. So some of the feedback that we are requesting, because ours is out for peer review at this point, is we basically go through a set of screening steps that talk about the things to look for. We describe, what direct identifiers are, which are typically, we often call them, refer back to the HIPAA 18, which is, name, address, social security number, medical record numbers, fingerprints, faces, email addresses, all of those things that can be directly linked to a person. And then also discuss a bit more about the indirect identifiers, which basically are unique information that, when you have enough in combination, could lead to the identification of a person. There are lots of different ways for people to de-identify data, and Dave Fearon on our team has taken a stab at creating sort of a high-level guide for some de-identification techniques. But this is one thing that, we know that a lot of curators are not going to be comfortable with doing themselves, nor necessarily should it be your responsibility, because you don't necessarily want to sign off on, oh yeah, this is ready to go. So it's more about spotting what could be problematic and how to communicate that back to the depositor. So as you can see, some of the feedback we're looking for, as we go through our review process, is that logical? Is there enough information present to make a novice curator confident, especially about approaching a depositor, because sometimes that can be difficult, where you're like, am I asking the right questions? Are the examples we provide relevant and clear? And then should the steps for screening that Dave created be a separate appendices for that particular primer, or should it be its own primer? Because we definitely know we could go that direction. I mean, we were just talking, of course, about medical images. That could potentially be, you know, how to de-identify medical images might be something in that primer, or it could be its own. I mean, it's hard to tell because this can be a very deep topic. And one of the things that actually happened is because this is a deep topic, we are going to split out what we have right now as one into two. We're going to have a general overall human subjects primer, but we're also going to have one on consent forms. The complexity of reviewing consent forms it can be very difficult because some of it is how are you looking at the language and where might you find language about consent, perhaps not in a consent form, but maybe in interview instruments or things like that that might contradict what the consent says, especially all of this pertaining to data sharing, and what kind of problematic language you might encounter, and how you might want to relay those concerns back to the depositor and how they should talk to the IRB about either needing to seek reconsent or confirmation about whether or not they can actually share something. So some possible future directions, our team being, you know, part of the DCN and part of the DCN education work group, is we were thinking about having a workshop specifically around human subjects data because it is a very big topic and one of great concern. Also, we thought about having, again, like I said, a dedicated primer on data de-identification methods if that's something that folks think would be useful. And of course, we're open to lots of other ideas. So that's ours at a high view. I look forward to your feedback. And since we only have 3 minutes left, I'll end in case people have questions.
Thank you so much, Jen. So right now, I guess we'll take any questions from anyone. I also want to let you know that is our repository address if you want to look at all of the currently published primers on there. And one other thing we do, if this has inspired anyone to want to attend one of our workshops, we do have an upcoming biomedically themed workshop with the National Institute of Health and National Library of Medicine. More information on that and the application can be found at our website, datacuration.network.org, under the Events tab. And I do also want to thank all of our speakers here, Fernando Rios, Janine Finn, Peace Awesome Williamson, Raina Murray, John Watts, Courtney Kearney, Helen Marie Sheridan, and Jen Dara. Did anyone have any questions? Please type them in the chat. And it looks like Majorie says, thanks for all the work that has gone into these and thanks for great presentations. Thank you very much.
All right. Thank you, Hannah. And to all of our presenters. If there are no questions, which doesn't look like there is, I see no typing. Appreciate all the presenters and all the hard work that y'all presented to us today. Thank you, the Texas Digital Library and the Texas Data Repository Steering Committee for coordinating the topics in Research Data webinar series. And many thanks to Jessica Joy Logan for curating this webinar for us. Have a great day.